Hello, everybody. Welcome to another exciting day of geometry. Today, you can see on our Do Now slide, our topic for today is going to be midpoint and distance formula. We're going to start looking at these two. Our objective for the day is that I can use the points from coordinate plane to find the coordinates of the distance between the endpoints of a line segment. So, what you're due now is make sure you go do your daily attendance form, check your Google Classroom, and you're going to open the notes and the activities for Unit 2.2 labeled Midpoint and Distance Formula. You're going to complete your bell ringers on Poll Everywhere at pollev.com. You can see the Google Classroom for the link. Looking forward into the next week, we will be covering midpoint and distance. We have digital notes, we have practice activities, and then you're going to have your Delta math assignment. So right now, take a moment, go do everything you're supposed to be doing now, and come back and see me when you are ready. All right, welcome back. So you should have your Unit 2.2 digital notebook open. You should have your Activity 2.2 open as well. Go ahead and get those two things open. We're going to start with the notes, and then we're going to roll into our activity. So your poll everywhere should look like this. And, oh, not this, sorry. Should look like this. And you should be telling me how well do you think you know the midpoint and distance formula. Your options are so well you could teach the class. All right, I guess, but not awesome. Not very well. Teach me. Or I didn't even know there was such thing as a midpoint or distance formula. Go ahead and answer that question and poll everywhere so I will be able to get your results. Now, get this going here. Hopefully you have your notes already opened and you're just waiting on me. I appreciate you waiting. We're going to start with the midpoint. And the midpoint is the halfway point between two coordinates. And a midpoint splits a segment into two smaller congruent segments. So we talked about congruent means that they have equal measure. And our notes here are telling us that A is the midpoint of segment CR. So over here we have segment CR. A is going to be put in here at the midpoint. So that means that line segment CA is going to be congruent to line segment AR because we cut this in half, and half plus half equals whole. So remember, we put our tick marks in here to show that these are equal measure. Here's a great example. We have segment GM that is shown below. If E is the midpoint of G and M, we want to find all of these measures. So we want to find GE, EM, and GM. If we look over here in this column, it says since the description says that E is the midpoint, the first thing we should do is show that it's true in the picture by making the tick marks. So here we have a tick mark here and a tick mark here. Perfect. So now what we want to do? Well, let's look at our math, our drawing, and let's tell our math story. So here we're going to draw it out. We have it labeled GEM. We have our tick marks. And this problem goes ahead and gives us two expressions. We have an expression over here on line segment GE that says 4x plus 6. And then over here at line segment EM, it tells us that 7x minus 9. So if we have two expressions that are equal each other, we can use each one to find x. And so when we find x, we will be able to find the measures. So to find x, we know over here that GE is equal to EM. We're going to plug in our expressions. So our first expression over here is 4x minus 6. And then our expression for EM is 7x minus 9. Excuse me. Oh no, my little mouse just died. All right, we'll keep going. So now we've put in our expressions. Now let's start solving through. We're going to work our way through, and we can go ahead and get our x to one side. So we're going to subtract 7x from both sides. And that's going to give us negative 3x plus 6 equals negative 9 on one side. And then we're going to go ahead and let's get rid of that 6 on the left side. And to do that, since it says plus 6, we are going to subtract 6. So take minus 6 here. Negative 9 minus 6 is 15 here. That leaves us with our negative 3x equals negative 15. So we're going to, this is a multiplication. So to undo that, we divide. So we're going to divide by negative 3. And we're going to do that to both sides. And then we get x equals 5. Okay, so we found x. Now what are we going to do? That's right. We're going to sub x in for, sub 5 in for x, and it's going to give us the measure of each of our pieces. So let's start with this piece. We have line segment GE, and we know that it is 4x plus 6. We have that here. GE equals 4x plus 6. We're going to sub in 5 for x. We know we've solved up here. We know that's our answer. So we're going to just keep solving through to find out GE. So 4 times 5 is 20. And we're going to keep bring our plus 6 down. So 20 plus 6 is 26. So GE equals 26. Awesome job. So now we've solved for GE. So we know this right here. Now, let's go and let's find EM. So we want to find this piece. And we know that line segment EM is 7x minus 9. So we're going to write that out here. EM is 7x minus 9. Well, we know x is equal to 5. So we're going to sub 5 in here. So 7 times 5 is 35. We're going to keep bringing our minus 9 here. And then we're going to just subtract through. 35 minus 9 is 26. So EM equals 26. Guess what? If these two line segments are supposed to be congruent, and that means they have equal measure, guess what? We just proved that they have equal measure. Bam, a little self-check. Next, the last thing we want to find is the total length right here of GM. All right, so we're going to come down here. And we know that GM is equal to line segment GE plus EM. So we're going to write that out here. GE plus EM. We've already solved through for segment GE and EM. We know how long they are. Their GE is 26 and EM is 26. So sub those in. Then it gives us 26 plus 26 equals GM. 26 plus 26 is 52. So line segment GM is equal to 52. I know. I feel pretty excited about it myself. Let's give this an erase. And we'll see what else we have going on today. I did a lot of scribbles. Sorry, guys. All right. Next. It says, is a midpoint different on a coordinate plane? No. The midpoint is the halfway point between 2 points on a coordinate plane. So even if we take our line segment and we put it on a coordinate plane like we did here, we have line segment MD, and it just gives us coordinates. So for M, it's -4, 5, and for D, it's 4, -7. And the midpoint right here at I is just a point that divides this whole segment, into 2 congruent parts. So if we put the midpoint here, that we know that line segment MI is going to be congruent to line segment ID over here. And we mark that they're congruent by putting the little tick marks right there to show that they're the same. So now what are we going to do with this? Now that we know that it's the same on a coordinate plane, we are going to be able to find the midpoint of 2 points on a coordinate plane by using a formula and subbing in the points that are given to us into the formula. So this is really important, huge, big. Should we draw stars around it? I'm not sure. This midpoint formula right here in this teal box, you need to write this down. You should probably try to commit it to memory. We are going to be using that. I always like to, when I am doing things that involve a formula that all I have to do is sub in, I always like to write it real small at the top of my paper, or real big, it just depends. And that way I have it right here where I'm doing all of my work. So, okay, the midpoint formula is M for midpoint equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So here's the thing. Where are we getting this x1 and x2? What kind of craziness is this? You're going to be given the 2 endpoints. One endpoint is going to be x1, comma, y1. You're going to get an ordered pair that tells you where it is on the coordinate plane. And your other endpoint is going to be x2 and y2. You're just going to label it. And then you will sub in the numbers. So whatever is the x value on this point on your coordinate plane, you're going to sub in there. Whatever the x value is for this point, you're going to sub in here. I know, super easy. So when you find the midpoint of 2 coordinates, you are going to get another coordinate. It's going to be a number, comma, a number. And that's going to be where the midpoint is on the coordinate plane. So let's practice. Go ahead at the top of your page, write down the midpoint formula. M equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So, pardon me, we're going to use the midpoint formula to solve through an example. So m equals, I'm going to write out my formula here on my paper. There we go. Just check it. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. Got it. All right. Let's turn the my other camera on. And we will see where we're at. Oh, no, don't want to go back. Uh-oh. Okay. We'll do the line. All right, so we have our midpoint formula. Let's click back over here and let's see our, not what we want. Our point that it's given us for our example. It says, find the midpoint of the following coordinates R1 and R2. So R is going to be 4, 1, and S, is going to be 2, -5. So we have our midpoint formula. We have our points, and we're just going to sub in the numbers for the x's and y's. Let this pull back up. Sorry, guys. So, here we have our midpoint formula again in red right here. Now, we're going to sub in our numbers. Where do we get these numbers from? So we need x1 and x2. So we need x1, x1, x2. Then we need our y's. So we need y1 and y2. Do y'all see where those numbers are coming from? So in our ordered pair, we have our x and our y. And this is another ordered pair for a point, and this is x and y. So we just take our x's and our y's and sub them in. Then we're going to go through and we're going to work out our math. 4 plus 2 is 6, so it gives us 6 divided by 2. And 1 plus -5 is -4 divided by 2, pardon me. So we can simplify these down and get whole numbers. And we get over here, 6 divided by 2 is 3. And -4 divided by 2 is -2. So we have another ordered pair for our midpoint. This is telling us where our midpoint is. So, don't worry, we're going to get some more practice. In number 2, A is the same distance from B as it is from T. So, we're solving for A is the midpoint of segment BT, B has coordinates of 2, 7, and A has coordinates of 6, -1. Find the coordinates of T. So we don't have our other endpoint. But we have our first endpoint and our midpoint. So it tells us we're going to use a counting method to get there or to figure it out. So what we can look at, we need an x value and a y value. So for x, we're going to follow the blue lines. So from our first endpoint to our midpoint, how do we get from 2 to 6? That's right. We add 4. And if this is equal, this line segment is congruent to this line segment. If we want to get from one point to one point, we add 4. If we want to get to this point, guess what? We add 4 again. So when we get 6 and we're going to add 4 more, we're going to get 10. So our x value is going to be 10. Now we need to find out our y value. Let's see what the numbers give us. We have 7, and our midpoint is -1. Well, how do you get from 7 to -1? And the answer is you subtract 8. So 7 minus 8 is -1. If these two pieces are congruent as they're marked with the tick marks, we're going to do it again to get this next y value. So -1 minus 8 is -9. So just using the number line to figure out your missing endpoint. All right, let me get all this erased. All right, so now you're going to do some practice on your own. Yay! So, the first thing you need to do is it says we're going to use the midpoint or find the midpoint between the following coordinates. So, we're going to use the midpoint formula. Let's see. And our A endpoint is -6, 10, and our B endpoint is -4, 8. So I have my midpoint formula set up here. These are my endpoints here. We're just going to sub in these numbers here. So we have m equals, we need x1. So A will be our 1 and B will be our 2's. So x1, -6, plus x2, which is -4, divided by 2, plus, y1, so 10, plus y2, our other y2's over here, divided by 2. Oh, pardon me. So, we've got a bunch of numbers, and now we just need to solve through. We can say that -6 plus -4, -10 divided by 2. 10 plus 8 is 18. 5 plus 18 divided by 2 is 9. So m equals -5 plus 9. I'm sorry, that's not a plus sign. That's a comma. So m equals, see, you got to be careful, guys. I'm adding and shouldn't be, and nobody's here to correct me. So this point should be -5, 9. Shoo-wee. I get to going by myself All right. So in your gray box, your midpoint should be -5, 9. Our next question is number 2, and it says A is the midpoint of segment BT. B has coordinates of 4, 2, and A has coordinates of 6, 4. Find the coordinates of T. So we just had a problem like this. And just like when we were doing segment addition and angle addition, let's draw it out. So A is the midpoint of BT. So we need a line segment labeled BT. And A is the midpoint. And we know that B has coordinates of 4, 2. And A has coordinates of 6, 4. So here we go. We have it drawn out. We have our line segment BT. We have A as our midpoint. And B is at 4, 2. A is at 6, 4. And we do not know what T is, but we're getting ready to find out. So we need to look at how do we get from 4 to 6. What's our jump here? Correct, +2. So what does our jump to here need to be? +2 again. So our x value would be 4 + 2 is 6. 6 + 2 is 8. Now we need to figure out our y value. How do we get from 2 to 4? 2 to 4. Again, we add 2. So if we did add 2 here, we need to, correct, add 2 here. And we get from 2 + 2 is 4. So 4 + 2 is 6. So our coordinates for point T is going to be 8, 6. So in your gray box, you're going to put 8, 6. So we've talked about midpoint. Now we're going to talk about distance. So distance is how far it is from one point to another. And so when you're told to find the distance between 2 points, you're basically being asked, how long is this segment? And a number line shows a good visual of what is the distance between the 2 red dots, or what is the length of the segment connecting them. So all you would have to do here is to try to count how far they are from each other. And on this one, if you start at -2 and we're going to 3, we're just going to jump. So 1, 2, 3, 4, 5. And right here we see 5 units, however long these units. They could be centimeters, inches, miles. So how do we find the distance between 2 points on a coordinate plane? Well, we have a handy dandy formula to help you. Here is our formula that we will use to find the distance on a coordinate plane when we are given points A and B. The distance can be found using this formula. Again, we're going to have be given the points. You're going to plug in the number. So down here we have point A and point B. Point A is going to be our X and Y1, and B is going to be our X and Y2s. And the whole distance is going to be this right here. So finding the distance between 2 coordinates will give you a single numbered answer. It won't be like a coordinate point like the midpoint was. and it will never be negative. So if you are coming up with two numbers or you're coming up with a negative number, we need to check your math. So some examples. It says find the distance between the following sets of coordinates. So number 1, here's a fun fact. If a segment that you are finding the length of is a vertical or horizontal line, you can literally just count between the points. So this is a vertical line, and we can count the point or the segment pieces in between. So we have these little boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I'm sorry, 10, 11. 11. It's 11 units long. Easy peasy lemon squeezy? That's what I think. But that only works for a perfectly horizontal line or a perfectly vertical line. So, number 2 shows us our formula in action. So, we have been given points. We have M, which is going to be our 1, and N, which will be our 2's. That's a 2. Sure is. We have our formula. D, distance, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, sounds good. Pardon me. Now all we have to do is sub in our numbers. So our M is our 1, so we have negative. This is our x and our y. And on M, this is our x and our y. So we come down here, and it is x2. So x2 minus x1 squared. And then we have our y2. So our y2, our y2 minus our y1. That's where those numbers came from, squared. And we're just going to solve through. So that gives us 2 minus negative 1 squared plus negative 4 minus 2 squared. And that brings us down to 2 plus 1 squared plus negative 4 minus 2 squared. 2 plus 1 is 3 squared. Negative 4 minus 2 is negative 6 squared. 3 squared is 9. Negative 6 squared is 36. We're still adding those together. We get 45. The square root of 45, which is 6.7. 6.7. If you are not sure where these numbers are coming from, I suggest that you copy my lines when I draw them of where we're pulling these numbers to sub from. You can always pause the video. It is an option. So, now we have a couple practice problems. It says find the distance between the following sets of coordinates. Number 1 is a horizontal line. And what did we say we could do on a horizontal line? That's right. We just have to count the units in between the endpoints. So we have 1, 2, 3, 4, 5, 6, 7 units right here on this line. So on the gray box, you would say 7. 2 gives us 2 points, gives us 2 endpoints. So we're going to use our distance formula in order to solve the distance between these 2 points. So on my paper, just like I did for the midpoint formula, I'm going to give myself the distance formula, which is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, I got my formula. My points are Q is 2, negative 3. 2, negative 3. And then R is 5, comma 1. All right, I have it all written out. Let me show you on my end what my paper looks like. So here's my distance formula. Here are my 2 points that I'm going to sub in here. So let's start. D equals the square root of, so x2, so we're going to use our Q is 1 and our R is 2. So x2, 5, minus x1, which is 2, squared, plus x2, or I'm sorry, y2, which is going to be y2 minus y1. So y1's over here. Negative 3 squared. We're going to go and we're going to just solve through. So 5 minus 2 gives us 3 squared plus 1 minus negative 3 gives us 4 squared. 3 squared is 9 plus 4 squared is 16. So we still need that. So 9 plus 16 is 25. We need the square root. And the square root of 25 is 5. So D equals 5. It's a weird looking 5. Great job. So over here, we're going to say D equals 5. So what we have next is our practice. If you feel like you can go ahead and get started on this, go ahead. If you would like to work through a couple of these together, we're going to do that together. So we have 6 problems, and then we have 6 answers. So whenever you find an answer to one of these questions, you're going to come to the answer tile. You're going to cut, and then you're going to paste it in to whichever corresponding tile works for you. All right, let's Let's do one distance and one midpoint, and then I'm going to set you off on your own to finish these up. So we'll start with find the distance between points P and Q. So we already have our distance formula on our paper that we just wrote on. I'm going to draw a little line there. And point P is at 2, 5, and Q is at 4, 8. And so we're just going to sub in. D equals, let me get my camera back. We're going to be down here. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We're going to do a little math. 4 minus 2 is 2 plus 8 minus 5 is 3. 2 squared is 4 plus 3 squared is 9, and we still need the find the square root here. If you want to put it on every line you can. So 4 plus 9 is 13, and the square root of 13. And then D, you can leave it at the square root of 13, or you can find the square root of 13. If you want to use your handy dandy calculator, it can either be the square root of 13 or D equals 3.6. 3.6. So you'll go back into your notes. We'll go to our answers, our matching tiles, and we just so happen to have a square root of 13 or 3.6, and we're going to put that in over into our tile. So let's go back and we will do a midpoint. We'll do this midpoint right here. It says find the midpoint between the coordinates C and D. Let's draw it out. I'm going to go back to my page that has my midpoint formula on it, and we're going to say point C is 3, 2, and D is -3, -1, and we're going to sub in for our midpoint formula. And we're going to, since we're looking for the midpoint, we're going to get an ordered pair. So let's just sub it in. M equals x1, which is right here. So this will be our 1. This will be our 2. So x1, 3 plus x2 divided by 2, comma, y1, which is 2, plus y2 divided by 2. Now that we have everything filled in, we're just going to solve through. So m equals 3 plus -3 is 0. 2 plus -1 is 1. 0 divided by 2 is 0, and 1 divided by 2 is 0.5. So the midpoint for these 2 points right here is 0, comma, -5. That's going to be your midpoint. So now that we've got 2 of those examples done, I want you to finish working through those. If you'll go back to your Do Now slide, you'll see that your homework is to finish your drag and drop 2.2. We'll come over here and look at your drag and drop, which is very similar to your examples. You are going to find the distance and the midpoint for each one of these. Each one of these. You have 8 problems. You also have your tiles over here. So when you solve for the midpoint of the coordinate points a -2, -3, and -2, 4, and you come over here and you're like, this is the midpoint. I don't know if this is the right answer, so don't trust that. You're going to cut, and you're going to come up here, and you're going to paste it into the midpoint box. Bam, just like that. You're going to go through and you're going to do that for each distance and midpoint, and all your answers are on here. So if you get an answer that is not one of these answers, check your math, because something is wonky. Now, we will pick up with going over our activity 2.2 tomorrow. If you have any questions on your notes or on your activity, please reach out to me. I'm available via email, phone call, or remind. If you have a question, comment, or concern, please make sure that you use the I Need Help link found in your Google Classroom, and I will get back to you however you have noted for me to contact you as soon as I possibly can. If we will pick up here tomorrow, guys. Have a great night, and I will talk to you soon.